Today we're going to look at the effect of a magnetic field on a moving particle, a charged moving particle. We know that there's going to be some force, but we don't yet know where. This particle is positive and moving upwards. So we remember the right-hand rule, and we use our pointer finger to point in the direction of the velocity. Our middle finger is going to point in the direction of the magnetic field, which is into the board in this case. And we're going to use our thumb to be perpendicular to the velocity, and so it'll point out, meaning that the force acting on the particle is headed to the left. Now the force is always going to be perpendicular to the velocity, so it'll cause the velocity to change direction while leaving the magnitude the same. So as the particle continues to move forward, the velocity will change, and so will the acceleration, because it always has to be perpendicular to the velocity. As it keeps going, the velocity will keep changing, and so will the acceleration, so that the particle is moving in a circle. And the force and acceleration are always pointed towards the center of the circle, making it centripetal acceleration. Now what if we were to have a negative particle in the same field? As we know with electric fields, positive charges are usually drawn one way, while negative charges are drawn the other way. So if we were to use the right-hand rule again, our pointer finger would normally go up because the particle is moving up, if it were a positive particle. Since it's not positive, though, we have to put our finger down. Our middle finger is still going to go into the board, the direction of the magnetic field, and then our thumb comes out at a 90-degree angle. So, the negative particle will move in the opposite direction of the positive particle. It will also end up moving in a circle, just in the other direction. So if we were to have a magnetic field that pointed out of the board, a positive particle moving to the left, what direction would the force be on? Well, we know that the velocity is going this way, and since it's positive, we don't have to reverse our fingers. The magnetic field is pointing out of the board, so the force must be pointing up in order to be perpendicular to the velocity. The particle will then continue to move in a circle. This can be very useful because scientists and researchers will use this knowledge to find out the charge of a particle, so then they can use the particle for other tests and experiments once they know the charge, based on what direction it moves in a known magnetic field. Since it's also in centripetal acceleration, we can use the equation A equals v squared over r, where v is velocity and r is radius. This can be used to find various things, such as like the radius of the circle that it's moving in, or the velocity. It can also occasionally be used to find the force.